Good day, class. It's Sir Capistrano again, and we're here for, I think, the very first video or lesson for our subject Physics 1, General Physics, wherein we will be talking about motion along straight lines, and later on in the video, we'll be talking about motion with constant acceleration. So, this video actually is not. A formal discussion of motion along the straight line. So, in our past discussions, we already talked about some of this straight line motions or motion along straight lines, wherein we talk about displacement, we talk about velocity, and the like. So this video actually will talk more about the derivation of the formulas that we will need to use regarding the motion along the straight lines. And later on in the course, or maybe next week, we'll be having another video wherein we will be utilizing this derived equations regarding motion along straight lines and constant acceleration for in rather in solving physics problem or what we call kinematics problem. So for today, we will be just focusing on derivation of the formula. So as you can see here, I actually have here blank slides. So by blank slides, we will be we will be using the brute force method for deriving the formulas. So for the equation one, for the first equation that we need to understand, we just write here not EG, that should be EQ. We have here our EQ1. Our EQ1 or our equation 1 is actually the simplest equation that we will be discussing today. It talks about more regarding our displacement, or it's just talk about displacement. And by displacement, as you have may remembered on our past discussion, we actually use this notation, delta x, or what we call the change in x, which is basically just a change in position. So if you have two positions, say you have here your x1, or rather, let's use x naught, or our initial position, which is in here, and we have and our object traveled towards a straight line, which is not that straight, okay, straight line, wherein our final position here is our x, right? So that is our final position. But basically, if we need to get the displacement between our x naught and our x, we just need to get their difference. So if the object move from our x naught towards the x, we will just have here our x naught, our delta x will be x minus x naught. So since our x is moving in the right direction or towards the final position, we will or our object moves from our x naught towards the x, we will have here a positive displacement. And if the object moves from the final point, which is x, towards the x naught, we will have there the negative displacement. Meaning to say, even if this is a straight line, we will incorporate a sense of direction since displacement is a vector quantity. So, uh, vector quantity is what we have discussed these past few weeks. So, that is our first equation, or our displacement equation. So, our next basic equation is our time. For our equation 2, we have here our time. We will designate time, or we will write time as t, because for later convenience regarding how we write our equations later on. But basically, when we talk of time, it is just the final time or what we say t2 minus t1. So that will be our time. So bakit ganun ka-importante yung time? As you may have remembered, if we have uh, motion and gusto nating makuha yung rate ng movement ng isang object, we need to take note of the time para makita natin kung gaano ba kabilis yung rate ng movement natin. So therefore, we have there our time. And by time, remember lang class, time is always positive because as the arrow of time states, time is ever moving forward. You cannot move backwards in time. Okay? So, that is our first two equations regarding our motions along the straight line. As you may notice here, wala pa masyadong complexity yung sinasabi natin. But basically, when we talk of time, it's just if you have your initial position, which is our x naught, and our final position, which is uh, x. Our time there will be simply the time you started the movement. Say you started from our x naught towards our x or yung ating time 2, lagi yung moving forward. So, kapag naging baliktad naman yung motion mo, say you started at x and you finish your movement, let's change the color. Say you started at your final position, which is X, final position, finish line, kumbaga. If you started at X, then you move towards the negative direction, still you will have a positive time because you will note this as your T1, then you will note this as your T2. So, hindi tayo pwedeng magkaroon ng negative na time. Okay? So, let's move to our third equation, which is actually, ito na yung meron ng movement. By movement, we mean velocity. So, by velocity, velocity is actually the change or the rate of change in position, in displacement pala. It is the change in displacement, or it is the displacement. So, like that. It is the change in position over time. So basically, when we talk about velocity, it is simply, or by average velocity, it is simply average the change in position, or simply our displacement over time. Basically, we can write this as x1 or x naught, not x naught, x, or final position minus our initial position over time 2 minus time 1, or we can actually write this as x minus x naught all over t. So that is our velocity. So this will be our equation 3. We have there our x minus x naught over t. So this will be equation 3. So again, average velocity is just the change in position over time. And when we talk about motion along the straight line, uh, mahirap kalimutan or mahirap set aside yung isa pang napaka-importanting concept ng movement, yung tinatawag nating acceleration. So, our next equation is about acceleration. Accele- Acceleration, wherein if velocity is the change in displacement or the displacement over time, Acceleration, on the other hand, is the change in velocity over a time period or time. So, in that, we actually have an equation regarding our average acceleration, wherein our average acceleration is just our a sub ab is equal to the change in velocity over time. So basically, this will be just our uh, Vx, or our final velocity, minus V naught x, or our initial velocity at a certain position, over time. So this will be our equation 4. So that is the four basic equations that we need to talk about when we are studying motions in a straight line. So first, we have there our displacement, which is simply the change in the position. So we have there x minus x naught, where x is our final position and x naught is our initial position. So displacement can be negative. And we have here equation 2, which is we have here our time, wherein time is just equal to time 2 minus time 1, which is actually always positive. So we have here our equation 3. We have here our average velocity. It is the change in position over time. So basically, it is displacement over time. So we have there our equation 3. Again, x is the final position. X naught, or x sub 0, is our initial position, and time is the period, or the time elapsed for the movement, and v over av is our average velocity. And lastly, for our basic equations, we have here our acceleration, wherein acceleration is the change in velocity over time, wherein vx is our final velocity, right? V naught x is our initial velocity, and of course t is time. Okay, so that is our basic equations for our motion along the straight line. So our next agenda, our next topic is regarding motion in constant acceleration. Meaning to say, the rate by which the velocity changes is constant. Ibig sabihin, kung nag-start ka na, ang acceleration mo ay 1 meters per second square, laging ang magiging acceleration natin ay 1 meters per second square. So, saka na natin pag-usapan kung paano natin i-compute later on yon. But basically, for now, let's focus on the derivation of the formula. So, having our equation 4, kung maalala nyo, ang equation 4 natin is we have there our average velocity, average acceleration. Our average acceleration is equal to Vx, or our final velocity, minus our V naught x, which is our initial velocity over time. So, using mathematical derivation or algebraic process ng pagko-compute, pwede nating actually baguhin yung formula na ito. So, given na constant yung acceleration natin, ibig sabihin yung rate ng pagbilis ay hindi nagbabago, we can actually multiply time to the acceleration. So we will have here our let's just use ax para hindi tayo malito. Ax, or just the constant acceleration, or you have there constant acceleration times time, is actually equal to Vx minus V naught x. And again, we can actually subtract or add Vx to both sides of the equation. Therefore, we can have there axt, or acceleration, times time, plus V naught x is equal to Vx minus Vx naught plus Vx naught, V naught x pala. So as you can see here, negative, positive, this will just cancel out. Zero yan. So we have there this formula. And if we perform commutation, we will have here Vx, or final velocity, can actually be equal to our V naught x. I'm just arranging the formula, plus our acceleration times time. So, anong sense no equation na to? Ah, pag sinabi natin na constant yung acceleration ng ating isang moving body, and we know kung ano yung kanyang initial velocity, we can actually compute for our final velocity without even knowing kung ano ba yung initial and final position ng ating moving object. So for example, you are given a problem in which ang sabi sa'yo, the car is moving at an initial velocity which is equal to 9 meters per second. Okay? And from that point, the car moved for 10 seconds. Okay? Masyado yata mabilis yung 9 meters per second. But anyway, for for explanation purposes. Then you have a constant acceleration which is, let's say, 0.5 meters per second square. Ibig sabihin, kada square seconds, bumibilis yung car mo by 0.5 meters. So, or nakapag-move yung car mo na by 0.5 meters. So, what you can do here is, kung gusto mong malaman kung ano yung iyong final velocity, you just need to plug in all of this values to your equation, wherein you will have Vx is equal to 9 meters per second plus our Ax, which is 0.5 meters per second square. Then you just need to multiply that to time, which is 10 seconds. As you can see here, you will have 9 meters per second plus this is 5 meters per second. Then you just need to add those two. Then you will have 14 meters per second. So that will be your final velocity without even knowing the initial and final position. So in here, class, we have here our equation 5. Given that our object, or the particle, or the moving body is in constant acceleration, wherein the rate of the change in the velocity is not increasing or decreasing. It is constant. Okay? So we have there our equation 5. So let's continue on with this problem. So basic or this method, wherein let's talk more about our average, average velocity. By average velocity, as you can see class, since average, kung maalala niyo yung lesson natin sa stat, average is just the mean, meaning to say, you just need to get the mean. Okay, so if you have two values of your acceleration wherein you have an initial value which is v not x, and you have your vx, you can actually compute for the average velocity. So by average velocity, you just need to average these two out. Since you have two quantities here or two values, our average velocity will actually be equal to our v naught or vx plus v naught over 2. So we have here, this is one of the simplest equations so far. This is our equation 6. Meaning to say, if you have two quantities of your velocity wherein you have a v naught like earlier, which our v naught earlier is 9 meters per second, then you have a final velocity which is 14 meters per second. If you are to get the average velocity, you just need to average these two out. So we have here our average velocity will be equal to Vx, which is 14 meters per second, plus 9 meters per second. By the way, class, pwedeng magkabaliktad yan since our operation is addition. So we have here 14 plus 9, divided by 2 pala. We have there 14 plus 9 is 23 meters per second over 2. So we have there 11.5. 11.5 meters per second. So, bakit ko ba ipinakita pa ang ano natin, yung ating average velocity. So, by average velocity class, we can actually use this if we are to compute for the average velocity using under uh, constant constant acceleration. So by constant acceleration, wait a second, please. So let's use equation 5 and equation 6. So by equation 5, as you may have remembered, our Vx is equal to our V naught x plus our Vx, ay, no, 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 plus our Ax t. So as you may have remembered, our equation 6 says that we have here, if we have an average velocity, our average velocity will be our v naught x plus vx all over 2. Okay? And as if we are to compute for this average velocity, so what we can do here actually class is just take our vx. Let's just substitute the value of our Vx here in our equation 5, which is this one, to the Vx here in equation 6. So, magkakaroon tayo dito ng ang ating average velocity will be equal to our V naught x or our initial velocity plus this V naught x v naught x. So, para hindi tayo malito, sulat natin siya in a way na alam nyo kung saan ang galing. So, we have here our v naught x plus our axt. So, we will have here our v naught x plus axt all over 2. Okay? So, in that class, we can actually simplify this equation wherein we can combine like terms, then we can simplify our fraction here, wherein we will have here our average velocity. Just remove this. Our average velocity will actually be equal to 2 v naught x plus our axt. Okay? And all of that will be over 2. Further simplifying this, we will actually have an average velocity which is v naught x, because 2 divided by 2 will be 1, and we have there plus 1 half ax t. So this will be our equation 7. So wherein this equation 7 will actually be useful for for further computation or further derivation of our formulas. And in here, as you can see here, class, our ax again, or our acceleration, is constant. So again, this will be useful if you want to know your average velocity kung hindi nyo alam kung ano yung maging final velocity. So by that, if example, you only have the value for your initial velocity and your acceleration in time. Say a car is moving for 10 seconds, then its initial velocity, or our v naught x, will be, let's say, 40 kilometers per, huwag natin gawin kilometers, gawin natin 2 meters per second. Then we have here our acceleration. Our ax will be, let's say, it is accelerating at a rate of, say, 1 meters per second. So what will be your average velocity? Again, dun siya magiging useful. Just need to plug all this in. So we have here 2 meters per second plus 1 meters per second square. Then you multiply that to 10, which is your time, 10 seconds. One of this square will cancel out. So we'll have there 10 meters per second, meaning we have 2 meters per second plus 10 meters per second, which is actually 12 meters per second. So that is the use of our equation 7. But if we continue on with this computation using this equation 7, so having this equation 7, wherein our average velocity is equal to our v naught x plus 1 half acceleration times time, or constant acceleration times time. As you have may remembered, we actually have a formula for this average velocity, wherein that is our equation number 3. Number 3 naman. Okay. Wherein our average velocity is actually equal to our Vx minus, not Vx, sorry, not Vx, not Vx. Our velocity is actually our x minus our x naught all over time. That is from our equation 3. At kung gagawin natin silang equal, kung titingnan nyo, parehas silang average velocity, meaning to say our x minus x naught over t is actually equal to our Vx naught plus 1 half axt, or our acceleration times time. So in here, class, we can actually just multiply time on both sides of the equation, meaning this time will cancel out. And if we multiply time in this side of the equation, we will actually distribute time towards our v naught x and our acceleration times time. Meaning to say, we will have here a quantity wherein we have here our x minus x naught is equal to our v naught x times time, or our initial velocity times time, plus 1 half our 1 half times our acceleration times time square. Okay. So, kasi t times t is just t square. Okay? So, and as you can see here, class, ano ba tong ano na to? Quantity na yan. Yan actually ay yung ating displacement, kung maalala nyo, from our equation 1. So, or in our symbols, it is our delta x. So, again, pwedeng maging useful itong equation na to, which is we name this as our equation 8. If you want to know kung ano ba yung naging displacement ng movement having your initial velocity, the time kung gaano nag-elapse yung gaano katagal nag-elapse yung movement, and your constant acceleration. Again, class, hindi ito mag-work kung hindi constant yung acceleration. And also, in this note, kapag tinranspose natin, by transpose, we added x naught, or initial position, to both sides of the equation, we can actually have our final position. So in here, using our equation 8, wherein equation 8 is our displacement, or our final position minus the initial position, that is equal to our v naught x, or initial velocity, times time, plus 1 half of the constant acceleration times time square. If you add, actually, if you add x naught to both sides of the equation, you will arrive at an equation which is this. So you have there x in one side of the equation, then you will have x naught here plus v naught, or initial velocity, times time, plus 1 half acceleration, or constant acceleration times time square. And this one, as you can see here, hindi na to displacement. Yan po ay yung ating tinatawag na final position. So, in equation 8, you can actually have your equation 9, wherein instead of just computing for the displacement, if the initial position is known, you can actually compute for the final position. Okay? At syempre, hindi nagtatapos dyan ang lahat. By hindi nagtatapos dyan ang lahat, again, one relationship na pwede natin dyang makuha. Kasi dito, kung mapapansin nyo, wala tayong final velocity ulit. So, paano kung gusto na natin makuha yung final velocity? Kasi kung mapapansin nyo, halos lahat ng natin, ng mga equation na ginamit natin ay magkakaiba yung pinukuha natin. For example, for equation 5 dun, kinuha natin yung Vx given, or yung final velocity natin given our initial velocity, constant acceleration, and time. But for the next set of equations, ang mga nakukuha na natin ay average velocity. We also get the displacement and the final position. So how about, do we have another formula for our final velocity? Of course we do. So again, we will be using our equation 8, wherein equation 8 is our displacement or our final position minus our initial position is that is equal to our initial velocity times time plus our the one half of acceleration times time square. So also, as you may have remembered, we have our equation 4, wherein equation 4, wait lang, hinahanap ko yung equation 4. Our equation 4 is our AX is equal to our final velocity or Vx minus our V naught over time. So what we can do here, class, is let's express this equation in terms of time. So via that equation 4, time is actually equal to final velocity minus, kalimutan ko yung x, our initial velocity over our AX. So, paano yung nangyari? I just multiplied time papunta dito, then cross multiplication class. So, multiply ko naman yung AX towards dun sa baba. And as you can see here, sa equation 8 natin, meron tayo actually mga time or t. So, again, para hindi tayo malito, let me just rewrite this wherein our time will be equal to our final velocity minus our initial velocity over our constant acceleration. So, let's just plug in this time dun sa mga time components ng ating equation 8 and we will arrive at an equation like this. So, we will have our displacement that will be equal to our initial velocity times the time. So our in time will be equal to our final velocity minus our initial velocity over our acceleration. And we will add that to one half of our constant acceleration times the square of the time, which is equal to our initial velocity minus our, not initial, that is final, minus our initial velocity over our AX. So, upon simplification of this, medyo mahaba yung simplification, pero sige, pakita ko. And I will be using black for the overall, ano, overall simplification. So, pwede natin gawin muna, we just multiply both sides of the equation with this quantity, which is 2 times 2 times of the acceleration. So again, ay, kalimutan natin yung square. Wait lang, kamagtaka kayo. Again, and also we need to multiply 2ax to this side of the equation. So, second class, I'm just checking something. Okay. So what will happen here is simply we just need to multiply our 2ax or 2 times our acceleration to our displacement, which is x minus x naught, and that will be equal to, since ang mangyayari dito class, we just need to distribute this 2ax towards this quantity and this quantity. Ang mangyayari class, maka-cancel yung ax sa baba, kung mapapansin nyo, pero mareretain yung 2. So magkakaroon tayo dyan ng 2v naught x multiplied to our vx minus our v naught x. Then, i-add lang natin yan yung 2 multiply natin sa 1/2, so that will be 1. And we have there our ax. So magkakaroon tayo ng ax squared dito. Pero as you may notice, we have here a square and ax squared. So, ang mangyayari ay makakancel out yung ax. Therefore, we'll be left with vx minus v naught x squared. Okay? So, proceed na lang sa not so simple simplification ito. So, I just retained here our 2 times the acceleration multiplied to our displacement. And we have here, we just need to distribute 2 v naught x, or our initial velocity, towards this quantities. So, we will have 2 uh, vx naught vx times our initial velocity minus 2. Then we have here our v naught x square, kasi v naught x times v naught x. So we have v naught x square. Then perform binomial expansion here. So we will have vx square minus 2 vx v naught x, and minus not minus, that will be odd, addition yan. So v naught x square. Medyo naging complex yung yung itsura ng ating equation, but as you can see here, may mga magka-cancel out actually dito. So, maka-cancel to kasi we have 2 vx v naught x and negative 2 vx v naught x. So, 0 na yan. Then, we have here our 2 v naught x square and v naught x square. So, negative 2 plus 1, that will be negative 1. So, instead of 2, ito ay magiging negative 1 na lang. Mare-retain lang yung ating dx. So, finally, we have this simplification wherein we have 2ax times our displacement, that will be equal to negative v naught x squared plus our vx squared. Okay? So, further simplification, magkakaroon tayo ng ganitong formula wherein we have here v, our final velocity will be equal to our v naught x squared plus 2 times our acceleration, that is multiplied to our displacement. Okay? And in that class, we have there our equation 10. So, halos patapos na tayo. And for the last equation, ito na yung last relationship na pwede natin gamitin. For this last relationship, we will be using equation 4. That is our this is not equation 4. Wait lang. This is equation 3. Sorry. We'll be using equation 3, wherein we have there our average velocity is equal to our displacement, or our final position minus the initial position over time. And also we can use our equation 6, or in our equation 6, as you may have remembered, is the average velocity is just equal to the average of the final and the initial velocity, wherein we will have here our vx minus v naught x all over 2. So, as you can see here, both of them have the parameter average velocity, meaning to say our x minus x naught, or our displacement over time, is actually equal to the average of our initial, that should be plus, initial and final velocity. So, of further simplification, we will have here our x minus x naught, or our displacement, will be equal to our final velocity plus initial velocity over 2 multiplied to time. So again, this will be our last equation. This is equation 11. So basically, class, we have there all of our equations that is involved in motion along the straight line. So, in summary, actually, meron lang tayong apat na equations na dapat mag-focus tayo dun regarding regarding motion for with constant acceleration. So, these are the equations for motion in constant acceleration. Wherein our first equation actually will be equation 5. That is one of the useful equation wherein we just have there our final velocity is equal to our initial velocity plus acceleration or constant acceleration times time. As you can see here, the visible parameters here, or visible yung present na ano na tawag na yung mga present na quantities ay yung ating time, final velocity, eh, final and initial velocity, parehas ng velocity natin, Vx and V naught x, and also we have there our acceleration. And another formula that is useful for constant acceleration will be equation 9, wherein for equation 9 we have there our final position, or in our final position will be equal to the initial position plus plus the product of initial velocity and time, and also the one half of the product of the constant acceleration times time square. And as you can see here, the present quantities here will be time. We also have there our positions, our x's, and we also have there our initial velocity and our acceleration. Another formula that is useful for motion in constant acceleration will be equation 10. Wherein equation 10 states that the square of our final velocity will be equal to the square of the initial velocity plus the product of twice our acceleration and our displacement. As you can see here, absent ang time, present yung ating positions, present ang ating velocity, yung final velocity, present din ang ating initial velocity, and present din yung ating acceleration. And for the last equation, that will be this equation, equation 11, wherein we have there our displacement will be equal to our final velocity plus our initial velocity over 2. All of the quantities multiplied to time. And as you can see here, uh, the present quantities will be time. We also have there our positions. We also have there our final velocity and our initial velocity. Kaya kung makikita nyo class dito sa list na to, pwede na nating gawa ng checklist or gawan ng mnemonics kung ano yung gagamitin yung equation for certain scenarios involving constant acceleration. So we have there an equation wherein yung ano natin ang absent, wala yung position. We also have an equation wherein we don't have the final velocity. That is equation 9. And for equation 10, we have there an equation wherein we have no value for time, or we don't have a specific value or quantity for time. And lastly, for equation 11, we have there an equation for constant acceleration that don't have the value for acceleration. But for all of these equations, as you may have noticed, hindi nawawala yung initial velocity. So, take note of that sa paggawa nyo ng mnemonics. Okay? So, in that, I will be ending this video. So, thank you and have a great day ahead. Bye!